Howdy crew! In this lesson we're going to dive into a review of partial fraction decomposition. This is a skill you practiced back in pre-calc, and it's a skill that is worth refreshing our memory on before we go to our next integration method. In this lesson what we're going to be looking at is a review of what partial fraction decomposition means and what it looks like, a couple examples, and then a reminder of some general rules that we're going to have to follow. Partial fraction decomposition, what does it actually do? It breaks apart a fraction that's already simplified into two component parts. So you want to think of it as being the same thing or analogous to factoring with polynomials. We know with a polynomial we can factor it down like something like x squared plus 2x minus 15 can be factored down into x plus 5 and x minus 3. That's with a polynomial. But if I had something like 1 over x squared plus 2x minus 15, and I had a situation where I wanted to break it down into two separate fractions that had those factors, I should be able to do it. Now, I've put ones just as placeholders. It might not necessarily be the case that the top of that fraction is a 1. Our job is to figure out what those numerators actually have to be to make that sentence true. So how do we actually do that? We're going to use the method of partial fraction decomposition to simplify this expression. First things first is we need to factor the bottom. We need to break down the denominator into those two component parts. And that you've become pretty proficient with so far. To factor that denominator turns out to be 3x plus 2 and x minus 4. So what are we actually going to do with that? So the decomposition part is breaking this down into two separate fractions. First fraction will have the first factor as its denominator. The second fraction will have the other. Now the problem is I don't know what the numerators need to be to make this equal to 34 minus 12x. So what we'll typically do is we'll put an a and a b in those spots before adding them together. My question to you at this point would be, if I truly wanted to bring what we have down here into what we have in the original question, what would we need to do? And the answer would be to find a common denominator, of course. I would need to multiply the numerator of the first fraction by x minus 4. Same thing with the denominator. And I would need to multiply the top and bottom of the second fraction by 3x plus 2 to make sure that I had common denominators here. Now let's go through and do that. If I multiplied the numerator up on top, I would have ax minus 4a plus 3bx plus 2b, just distributing through all of those pieces. Now if I go back to the original question said that my numerator really needs to be 34 minus 12x. The strategy now is to try to combine like terms if possible. Now we know that the ax and the 3bx, they are like terms because they both have x's in them. But I kind of want to be creative in how I combine them. I'm going to try to factor out that x at the same time. So I have that a plus 3b all times x. Now my constants, those are all going to be together in one spot there. Now here's where your Algebra 1 knowledge comes into play. In order to make this number sentence true here on the bottom, it has to be true that the number attached to the x, that's this piece, has to match the original question. So what I have is, it must be true that a plus 3b equals negative 12. In order for the coefficient in front of the x to get to our original question, it has to be true that a plus 3b equals negative 12. Now the same thing's going to be true for the constant. this negative 4a plus 2b is going to have to be equal to 34 to make that original question true. Now, if you remember back to your Algebra 1 days, that's a system of equations that you're able to solve. Now, how you solve that system of equations is entirely up to you. Sometimes making a nice substitution is easy. Sometimes using the method of elimination back from Algebra 1 is a good idea. For this particular one, I think elimination is easier. I'm going to multiply the top row by 4. Doing that, 4a plus 12b equals negative 48. Bottom row I don't have to touch. I can combine my rows together, eliminate the a. 12 plus 2 is 14. Negative 48 plus 34 is negative 14. And that tells me that b is negative 1. Now, of course, to find a, just like we did in Algebra 1, I'll go back to the easier equation. Certainly that's going to be the top one. I'll plug in b equals negative 1, and we'll solve that. Probably can tell straight away that a is going to be negative 9. Now, how do I actually use that to get my answer if I know what a and b are? From here, your final answer is just to break down that original question into those two pieces. In the a spot, we'll go my negative 9, along with my 3x plus 2 on the denominator. Putting a minus here, because my b is a negative 1, so I can throw that minus in between the fractions to have my x minus 4 on the bottom. Now, you might be asking yourself, why are we bothering doing this skill? You'll see when we start our next lesson with integration. Now, the second one has a slightly different component to it, and that is that x plus 4 quantity squared on the bottom. Now, it's already factored, which is nice. Our mind would automatically think, well, wouldn't I be able to break this down into just x plus 4 squared with our a on top? And that's almost true. The problem here is there's an extra component. And those two components look like this. Our first fraction in the decomposition will be an x plus 4 linear term, just like the last example. But there's going to be another term. That other term is going to be this quantity squared. We're going to cover why that is in our next lesson. Now that I have that, I'm ready to go to work. Looks like to get common denominators, the only thing I'm really going to need is to multiply top and bottom of the first one by x plus 4. I'll distribute through. I get ax plus 4a plus b. Now that has to equal my numerator in the original question, 10x plus 35. Now we got to think, how is that possible? Well, if you look down here, if ax is supposed to equal 10x, all my terms with x's are going to have to match, then it's automatic that a is going to equal 10, which is perfect. So now all I have to really look at is 3a plus b equaling 35. Well, how am I going to make that happen? Of course, I can plug in my a equals 10 and solve from there. 4 times 10 is 40, telling me that b is going to be negative 5. Once you have your a and b, it's just a matter of putting them into your composition, your decomposition. In the a spot, we'll go that 10. In the b spot, it needs to be a negative 5, so I can throw that minus in the front. Now, before we end this lesson, it is important to go over some general rules. What you're going to see in these problems, if both denominators are linear terms, when I say linear, I mean they just have an x as an exponent, then our numerators are just going to be our a and b. Nothing problematic there. If one denominator is squared, You're going to have one fraction with the linear version and one fraction with the squared version. That's what we just covered in the last example. When we had a quantity squared, we had one term with the linear version and one term with the squared version. There is one more example that you're going to play with, and that if the denominator has a degree higher than 1. So for example, if you had one of your fractions looking like this, x squared plus 4, for example. On the top, I just couldn't have a b. I would have to have bx plus c, starting that x power being 1 less than the power of the numerator. And again, we'll cover in class why that is when you come back to the room. So from here, when you're using partial fraction decomposition, get the bottom factored if it isn't already, set up your system of equations, and solve. Nice job.